A laser beam strikes on point A of a spherical segment made of glass with index of refraction n equal to 1.5. The radius of the whole sphere is r equal to 8 centimeter. The distance from striking point A to point E is a equal to 3 centimeter. Angle AED equals 19 degrees. The distance from center C to bottom side of the spherical segment is B equal to 3 centimeter. Angle CFD equals 90 degrees. If the incident angle θ1 on point A equals 34 degrees, what is the angle θ4 when emerging from point B? θ4 is angle between exiting beam and the normal line CB. Attention! Depending on the value of incident angle θ1, point D could be on the left or right of point F. You should decide which of the following graph to use. Depend on angle θ1. If the angle θ1 is quite large, then point D should be on the right side of F. If θ1 is small, then point D will be on the left side of F. So point D now is on the left side of F. When you do the calculations, you should decide the D point. So if D on the left side of F, now you should use this graph. If D on the right of F, you should use this graph. So given the following quantity, θ1 equal 34 degrees. A equal 3 centimeter. And B equal 3 centimeter. N equal 1.5. Radius R equal 8. And find θ4 equal to what? So I have θ1 equals 34. θ1 equals 34 at here. So θ1 equals 34. A equal to 3. A equal to 3. B equal to 3. B equal to 3. N equal 1.5. N equal 1.5. R equal to 8. R equal to 8. Then find θ4 equal to what? θ4 is here. Find this angle, theta 4. Now, to solve this problem, solution. We define some angle. Let angle E A C, I call this angle at Z. Angle CAD, this angle I call it theta 2. Angle ADE, I call angle as Y. An angle EDC, I call angle X. An angle DBC, I call this angle as theta 3. And the distance from A to D I call P. And distance from C and D equal D. Let's see the definition of angles here. So angle EAC, EAC, this angle is Z. EAC, this angle Z. Angle CAD, CAD, angle theta 2. And angle ADE, ADE, this angle is Y. And angle EDC is X. EDC, so EDC, this angle is X. Angle DBC equals theta 3. DBC, this angle is theta 3. The length A to D is P. And C to D equal to D. C to D is D. After I defined the angles and the length or distance, I can use some laws. Okay. Now, we consider triangle AGC. Cosine Z equal A plus B divided by R. Therefore, Z equal cosine inverse A plus B divided by R. Equal cosine inverse A is what? A equal to 3, B equal to 3, R equal to 8. So 3 plus 3 divided by 8. Cosine six divided by 8 equal 41.41 degree. So what I did is I consider triangle AGC. I consider triangle AGC so this triangle AGC. So A plus B is AG. AG divided by AC. AC is R, the radius. So this length AG divided by AC equals cosine Z. So cosine Z equal to A plus B divided by R. Then I find the angle Z. I can find the angle Z is 41.41 degree. Next point, I apply Snell's law Snell's law at point A. So Snell's law at point A So at point A, I apply Snell's law. So the error index of refraction is 1. 1 times theta 1 equal n equal 1.5. 1.5 times sine theta 2. So I have so 1 time sine theta 1 equal 1.5 sine theta 2. And theta 1 equal 34 degrees. Theta 1 equals 34 degrees. So I have here sine 34 degrees equal 1.5 sine theta 2. So on the left side, I have 0.5592 equal 1.5 sine theta 2. So 0.5592 divided by 1.5 equal sine theta 2. And 0.3728 equal sine theta 2. Therefore, theta 2 equal sine inverse 0.3728. $21.89 degree. And next step, I consider triangle AGC. Triangle AGC. AGC. For triangle AGC, I have GC A plus B time tangent Z. GC equal tangent Z time the distance from A to G, which is A plus B. So A plus B times tangent Z. Now, therefore, my EF equal to GC. Equal A plus B tangent Z equal 3 plus 3, A equal to 3, B equal to 3, time tangent 41.41 degree. Equal 5.292. Now, ED equal A time tangent Z plus theta 2 equal, okay, ED equals to A times Z plus C2. So E D E D equal A, which is AE times tangent Z plus C2. So we can find E and D. Equal to 3 times tangent Z equal 41.41 degrees plus theta 2. C2 we have, it is 21.89 degree. So this answer will be 5.965. So from these two figures, ED is greater than EF. ED is greater than EF. ED is greater than EF. So that's why point D is on the right side of F. Therefore, we cannot use this graph. D is on the left side of F. We cannot use this graph. We have to use this graph. This is the reason we want to compare EF and ED. So therefore, ED is greater than EF. Okay. Next step, we consider triangle AED. So y equal angle y equal 90 degrees minus bracket z plus theta 2. So equal 90 degrees minus 41.41 degree plus 21.89 degree, which equal 26.70 degree. And also, so AED, okay, what we have here is triangle AED, angle Y, this angle Y equal 19 degrees minus Z and minus C2. Because the sum of all angles of a triangle equal 180 degrees. Therefore, and this is 19 degrees already, so therefore y equal 19 degrees minus z minus c2. And also, cosine z plus theta 2 equal A divided by P. So we consider triangle A divided by P equal cosine Z plus C2. Therefore, my P equal A divided by cosine Z plus theta 2. So A equal to 3 cosine Z equal to 41.41 degree plus theta 2 21.89 degree. So this value give me the number as 6.677. Now, I consider triangle ACD. By law of cosine, I have d square equal r square plus p square minus 2rp cosine theta 2. So what we do here is we consider triangle ACD. So ACD. By law of cosine, I have d square equal r square plus p square minus 2 times rp cosine theta 2. So this is law of cosine. Therefore, d equal square root r square plus p square minus 2 times rp cosine theta 2. I can evaluate this expression. So r equal to what? R equal to eight. So 8 square plus p square, p is here, 6.677 square minus 2 times r equal to 8 times p equal 6.677 times cosine 21.89. So r square p square minus 2 times r equal to 8 times p 6.677 2rp times cosine theta 2 equal 21.89. So I can evaluate as this equation gave me the first two terms equal 108.58. The first two terms. The second term minus 99.13. So the answer is 3.074. Now, I consider triangle CFD. CFD. I write down sine of x equal b divided by d. So sine let's say triangle CFD CFD. So let's triangle sine of x equal b divided by d. Therefore, my x equal sine inverse b divided by d. Equal sine inverse b equal to 3 and d I have here 3.074. .4 degree. And next step, I consider triangle ADC. By law of sine, ADC ADC, and I use law of sine. I get following AD triangle ADC. I use law of sine. D over sine theta 2 equal R divided by sine x plus y. So D divided by sine C2 equals this R AC R divided by sine x plus y. So x plus y. I call this equation as equation 1. And I consider triangle C D B. I use the law of sine. I have D divided by sine theta 3 equal R divided by sine y plus 180 degrees minus x. For triangle CDB, we used law of sine. So this D divided by sine theta 3 equal this R, which is CB. R divided by sine this angle from the red line to the dashed line. However, by law of reflection, this is y. This is y. And this angle equal 180 degrees minus x. Therefore, this angle equal y plus 180 degrees minus x. So this is equal R divided by sine 180 degrees plus y minus x. So I put 180 on the front, 180 plus y minus x. So R divided by minus sine y minus x. Here I used identity about trigonometry. So I have used the following. Sine 180 degrees plus any angle. I call it alpha. Any angle equal so 180 degrees plus any angle equal to minus this angle of sine this angle. So this is one identity. So 180 degrees plus this angle is alpha, equal to minus sine on this angle. So this is alpha angle, okay, with this. And this one, I can further, I simplify as this R. So y minus x, and have in front have minus sine. So this one equal to sine x minus y. From here to here, I used another identity. Sine minus any angle equal minus sine this angle. This is another identity. This means the sine function is odd function of argument. So this one, from here to here, I used this identity. And this equation I call as equation 2. Now, from equation 1, here, the previous page equation 1, I got d divided by r equals sine c2 divided by sine bracket x plus y. Okay, I do like this. From equation 1, I will get another equation. From equation 1, I have d divided by r equal sine theta 2 divided by sine x plus y. This equation I call it equation 1 prime. And from equation 2, from this equation, I can derive a new equation as this. D divided by R equal sine theta 3 divided by sine x minus y. This one I call equation 2 prime. You see, on the left side, d divided by r, d divided by r for both these equations. Therefore, the right side, they must be equal. So I write down here from equation 1 prime and equation 2 prime, I got sine theta 2 sine x plus y sine theta 3 sine x minus y. So sine theta 2 divided by sine x plus y equal to sine theta 3 divided by sine x minus y. This is a new equation. From this equation I can find, therefore, sine theta 3 equal sine theta 2 times sine x minus y divided by sine x plus y. Sine 21.89 times sine so x minus y and x plus y. So x equals 77.4, y equal to 26.70. So this factor is equal 0.3728. This factor. And this factor equal to this value. And the bottom equal to this value. So I have here 0.2974. So theta 3 equal sine inverse 0.2974 equal 17.3 degree. Now I have found theta 3. Now I found theta 3, and by Snell's law I can find theta 4. So on point B, Snell's law so 1.5 sine theta 3 1 time 1 is the index of the air sine theta 4. So 1.5 sine theta 3 I have here 17.3 degree equal sine theta 4 0.446 sine theta 4 therefore theta 4 equal sine inverse 0.446 which equal 26.49.